let's learn about geometric probability and trivialize this AMC problem. So what is geometric probability? Geometric probability is the method of turning a combinatorics problem into a geometry problem. Let's see an example. Real numbers x and y are chosen independently and uniformly at random from this interval. Instead of jumping right into this harder problem, let's solve the problem that what's the probability that x is more than y. So, as all geometric probability problems should go, we start by drawing a diagram. This one is a square, but if there are three variables, x, y, and z, it would be a cube. This point is 0, 0. This point is 1, 0. This point is 1, 1, and this point is 0, 1. Note that choosing x and y inside this interval at random, that's basically the same thing as choosing a point inside the square at random, because each point corresponds to unique x and y, its coordinates. So now let's find the region of points for which x is more than y. It's not hard to see that it would be this region, because this line has an equation x is equal to y, and we know that, so then it's either this region or this region, and we know that it can't be the top left region because 0 is not more than 1. Therefore, it's this region. The area of this region is going to be 1 times 1 over 2 by base times height over 2, which is 1/2. And the area of this whole region is 1. So the probability that x is more than y is just 1/2. That makes sense because of its symmetry. Okay, now let's solve this AMC problem, which will be significantly harder. Real numbers x and y are chosen independently and uniformly at random from the interval 0, 1. Which of the following is closest to the probability that x, y, and 1 are the side lengths of an obtuse triangle? Okay. It looks a combination of geometry and combinatorics. Now let's prove that this is geometric probability. So let's just say we know that if it's an obtuse triangle, obviously 1 is going to be the side length opposite the obtuse angle, because 1 is more than x and y. So we want to convert this into a geometry problem, into basically an equation, because this obtuse triangle thing is sort of a hard condition. It turns out that that condition is equal to x squared plus y squared is less than 1. Why? That sort of looks like the Pythagorean theorem. If it's a right triangle, x squared plus y squared is equal to 1. So it's kind of intuitive to see that if it's an obtuse triangle, x squared plus y squared is less than 1. In fact, if it's an acute triangle with 1 as the angle opposite the acute angle, then it would be x squared plus y squared is more than 1. It's the generalized Pythagorean theorem. The proof involves law of cosines, which involves trig. Check out my intro to trig video for law of cosines. Anyway, let's solve this. So now that we know this condition, let's use geometric probability. So x and y are chosen randomly inside that range, so we draw this square, and a point is chosen randomly. Now the hard part. Which of these points it satisfies x squared plus y squared is less than 1? That sort of reminds us of a circle. So we draw this. But how do we know that this region works? In fact, if x squared plus y squared is equal to 1, then it would be the boundary of that region. Okay. Now, we're still missing something. We can't just jump right into this condition, but let's just ignore the triangle inequality for a second. So anyway, the answer would just be this region. It's not hard to see because we know that these 2 points have to be on the boundary, and the point root 2 over 2, comma root 2 over 2 is also on the boundary, somewhere about here. So this suggests a curve. But this is not correct, because by the triangle inequality, x plus y has to be more than 1. In the graph of that, it's just going to be this top half. So then the overlap, satisfying both conditions, is just this. And how do we find the area of that funky region? Well, we do the area of this quarter circle, which is pi over 4, minus the area of this isosceles triangle, which is 1/2. And the answer is going to be that over 1. This is going to be pi over 4 minus 1/2, which is pi minus 2 over 4. Pi is about 3.14, so pi minus 2 is about 1.14. 1.14 over 4 is going to be 0.57 over 2, which is about 0.29. If you like this video, please like and subscribe. Thank you.